I'm hoping that you have just finished watching Why Are Significant Figures Important. Remember, significant digits and significant figures are the same thing. So you have an understanding of why they're important. Now we want to work with them. So our first step in working with significant digits is to be able to count them. It's important to know that all digits are considered significant 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Zeros are a little uncertain, and so we're going to spend some time on zeros later, but let's count now with our significant digits. This first example, 34.5 grams, we have the 3, we have the 4, and we have the 5. So those all are significant, and that gives us 3 sig digs, or 3 significant digits. Here, 107.3 includes a 0. Zeros that are between other digits that are significant are considered significant. So because this 0 is between the 1 and the 7, that tells us it's significant. So 1, 2, 3, 4 significant digits in this particular example. So 107.3 meters has 4 significant digits in it. Our next example, 27 items, is an example of a counting situation. I count out, I have 27 items. When we count, we're considered to have an infinite number of significant digits. It's precise. We either have 27 or we have 26 or we have 28 items. We don't have 22.3 items. You can't have a half a person, for example. And so this has an infinite number of significant digits. Our next example, 230.00 meters, is an example with trailing zeros, zeros that follow. In our situation, we consider all trailing zeros significant. And so in this case, we have 1, 2, 3 trailing zeros. Those are significant. Our 2 and our 3 are significant. And so altogether, we have 5 significant digits. So far, we've looked at 2 examples with zeros. In each case, they're considered significant. Our next example, 0.0026 liters, is an example where we have leading zeros, zeros out in front. Those leading zeros are not considered significant. They don't tell us the level of precision of the measurement. They only tell us the placeholders. They're only placeholders for us. And so here, when we count, we would say that we have 26, or 2 6 are significant, and so we have 2 significant digits. Sorry, sig digs. Now this is an example that sometimes confuses people. We have 2 trailing zeros, but there's no decimal place, and because there's no decimal place, do we count them as significant or not? For our course and in Alberta Ed, we consider these significant. If you go online, you may find that they are not counted as significant. Here we count them as significant in our course. And so this gives us 4 significant digits, the 1, the 2, and the 2 zeros, so 4 sig digs. One of the ways to ensure that if you're uncertain, you can write this in scientific notation. So our decimal places here, we move 1, 2, 3 to the right, or to the left, so we have 1.2, and put in those 2 zeros, so that is clearly 4 significant digits times 10 to the 3 centimeters. And often I would encourage you to write it in scientific notation to make it very clear. So that is counting significant digits. Now that we know how to count significant digits, we need to work with them in terms of adding and subtracting and then multiplying and dividing. So we're going to move on to adding and subtracting. When we're adding and subtracting, in any case, we always round to the least precise. How we define the least precise is the fewest number of decimal places when we are adding and subtracting. So if I take 4.36 and I add to it 12.2, our least precise would be the 12.2 because there is 1 decimal place. That 1 decimal place is the least precise, and so when we round our final answer, we're going to round it to 1 decimal place. So we add this up and we come up with 16.56. We're going to round to this 1 decimal place, so we're going to cut that 6 off. We have to look at the 6 and decide when we're rounding, is that greater than 5 or not? It's greater than 5, and so we would round this up to 16.6 as our final result. Subtraction works the same way. So if I take 15.702 and I subtract from it 2.39, we subtract that out and I get 13.312. Again, we look for our least precise, and in this case our least precise is 2 decimal places, and so we want to round to 2 decimal places. So here's 2 decimal places. We're looking at this 2. This 2 is less than 5, and so we simply cut it off. We don't round it up. We have 13.31 as our final answer. Our next example is our next type of question is multiplying and dividing. And so let's go to multiplying and dividing. Let's multiply 4.27 times 2.5. We multiply that out and get 10.675. Here, again, we round to what's considered the least precise, but when we're adding or multiplying and dividing, rather than rounding to the fewest decimal places, we round to the fewest significant digits. So our 4.27 has 3 significant digits, our 2.5 has 2 significant digits, so we're going to round our final answer to 2 significant digits. Our 1 and our 0 are significant, so we're going to cut it off here. We look at the 6 that follows. That 6 is greater than 5, so we round this to 11, and our final result would be 11. Our next example is a division question, 56.2 divided by 105.2. Here, our least precise is our 3 significant digits, and so we get a rather awkward answer, 0.5342205. We want to round to 3 significant digits. This 0 is not significant. We have 5, 3, 4. Those are our significant digits. We look to the 2 that follows. That 2 doesn't force us to round up, and so our final answer is 0.534. And that gives you some practice or some work with adding, subtracting, multiplying, dividing, and counting significant digits. I encourage you to do the worksheet that is next in the lesson and some practice problems in the workbook. Have a great day.